So we're going to talk about the next of the repetition structures called a while loop. The for loop requires three things. We have to have somewhere to start, somewhere to end, and we have to change the condition. And all of those were neatly encased within those parentheses. We're going to need those same three things for the while loop, but we're going to split them up. So this is what a while loop might look like. We have some kind of a starting point. The ending point is going to be the condition inside of the parentheses, and we're going to have to change the condition inside of the while loop. So this is what it might look like. We're going to start with a counter variable set to 0. We're going to loop as long as our counter variable is less than 10, but inside of the loop we're going to have to change the condition. If we don't change the condition, just like with a for loop, if the condition always remains true, we will get stuck inside of this loop. So let's see what this looks like in Java code. So I can use a while loop to mimic the same thing that a for loop does. A for loop is really good at counting up or down. I can mimic these same things using a while loop. So I'm going to see if I can get a while loop to count from 1 to 10. I need some kind of a starting point, I need some kind of an ending point, and I need some way to change the condition. If my starting point is outside of the loop, I'm going to have to declare a variable. We can even call it count, and I'm going to give it an initial value, and then I'm going to have my while loop. The while loop is a container, so I need the opening and closing braces. The condition on the while is going to be the ending point. So while my count is less than 10, what I want to do inside of here is just display my counter variable, but the one thing that I must remember to do is to change the condition. I'm going to put a couple of exclamation points on it because it's critically important that I remember to change the condition. And so what I want to do inside of here is I just want to display my counter variable. So I'm going to build a print statement that allows me to just see what's in my counter variable. I don't really like just throwing numbers onto the screen, and so I'm going to put a text field telling me what this is. And then we have to change the condition, because if we don't change the condition, I will never be able to get out of this loop. And so I'm going to change the condition the same way that I did in my for loop. I'm just going to increment it by 1. So let's compile it and run it and see what it does. Just like my for loop, I would expect it to count from 0 to 9. If I wanted to go all the way up to 10, I'm going to have to set that less than or equal to 10. Compile it to implement my changes and run it one more time. And now we should get 0 to 10. So a while loop can do a really good job mimicking a for loop. I can count up, I can count down, I can count by 2s and 10s and 95s. But a while loop is much more flexible than a for loop. A while loop, because we can change the condition inside of the while loop, this adds a lot more flexibility. So let's see how something like that might work. So I'm going to reset my counter variable. Let's set count equal to something like 99, something that will allow me to enter the loop. And now I'm going to say while my counter variable is not equal to, let's say 0. 0 is going to be my sentinel value to exit the loop. And the way that I'm going to change this variable is to prompt the user for the new value of count. In order to do that, I'm going to need some kind of a scanner. So let me go up and create the scanner. So I have imported my scanner. The next thing I'm going to do is create a scanner to use, and I'm going to change the condition with that scanner. So I'm going to prompt him for a new number, and I'm going to capture the result. When I prompt the user for the number, I'm going to tell them what the sentinel value is, and the sentinel value is the value that they have to key in order to exit the loop. So let's compile this and run it and see what happens. So it's going to ask me for a number or a 0 to quit. That means as long as they continue to type in numbers, I will remain in the loop until I enter the sentinel value, and I will drop out of the loop. So let's do something inside of here that tells us that I am inside of the loop. So I'm going to say as long as they're not giving me the sentinel value, I'm going to tell them that that is a nice number. I'm going to use an if to do that. So as long as count is not equal to my sentinel value, I'm going to tell them that that is a nice number. I'm going to mirror back the number that they have entered, tell them that it's a nice number, as long as it's not the sentinel value. Once they hit the sentinel value, which is a 0, it should drop politely out of my loop. You may have noticed when we were building this while loop that the print statement inside of the if container is not surrounded by braces. And you may have wondered why it worked if it wasn't surrounded by braces. I affectionately call this playing with fire. We have to teach our Boy Scouts how to play with fire, correct? We send them up into the mountains, we give them wood, and we give them matches, and we say, build a fire. With the understanding that if we don't teach them how to do it correctly, they may potentially get burned. So we're going to find out when the ordinary people who created this thing called the Java programming language, they thought up something brilliant. They said to themselves, if people are going to build an if container to put logic inside, it only makes sense that they want to execute at least one line of logic. So they built Java in such a way that the if structure will automatically execute the first line of logic that follows it. That line of logic doesn't have to be surrounded by the curly braces in order for the if statement to recognize that that line of logic belongs to it or belongs in that bucket. I only need to use those curly braces if I want to execute more than one line of logic. An if structure, the while, the do while, all of these were created to automatically execute the first line of logic that follows it. I call it playing with fire because if I have built an if statement without the curly braces and I come back later and add another line of code to my if statement, if I forget to add those curly braces, that second line of code is not going to be tied to the if statement. Even if it's indented and it looks like it belongs to the if statement, if there are no curly braces around it, the if will only execute the first line of logic and nothing else below it, which means all of the lines of code below it will be independent of the if statement and will execute whether or not the if is true. So if your program is acting a little bit squirrely, one of the things that you can do is to check your if statement and see if you have been burned when you're playing with fire. So far, all of our looping structures have been using numbers for the counting values. I count up, I count down. My sentinel value has been numeric. So what we want to try next is a sentinel value that is not numeric. So I'm going to create a char variable that I'm going to call again. I'm going to set it equal to space, and then I'm going to create a while loop that is going to continue to loop as long as that sentinel value is not no. So the condition on my while loop is going to be while again is not equal to, and then I'm going to put a lowercase no here. I'm not playing with fire because there's more than one thing I need to do inside of here. So I am going to put my brackets. Inside of here, I am going to tell them that that was fun, and then I am going to change the condition. We must change the condition in order to ever exit the loop. So I'm going to create a print statement that says that's fun, and the change of condition is going to be, I'm going to ask the user, do you want to do it again? So we're going to say, that was fun, do you want to do it again? That was fun, do you want to do it again? And I'm going to continue through this loop until they say, no, I don't want to do it again. So let me build my print statement. So I'm going to tell them that that was fun, and the change of the condition is going to be a prompt to ask them if they want to do it again. And I'm going to capture that response into my again variable. So I'm going to ask them if they want to do it again, and I am going to give the user some idea of the values that I'm looking for. So I'm going to say y, lowercase y, and n here. And then I am going to read their response into my again variable using .next.charAt. I'm trying to get the character in position 0 of their input value. So there's a very good chance that the value that they key in is not going to be lowercase, and I am specifically looking for a lowercase n. So the next thing that we should do is probably force the input to lowercase, and I am going to force it to lowercase and put it back into the original variable that we are checking the condition for. And the way that I force a character to lowercase is I use the word character with a capital C and then 2 lowercase. Anything I put inside of these parentheses should be a char, and we'll force it to lowercase. And what I am trying to force to lowercase is the variable itself. So I'm going to put a char value inside of these parentheses. It is going to force that to a lowercase, and it's going to overwrite whatever was in again. So let me compile it and see if we can execute this. All right, so here is my last and final loop, and it says that was fun, do it again. So as long as I type in anything, it is looking for a lowercase n. If I were to type in a capital N, that is what it's looking for to execute. Let me run it again. You want to do it again? And if I type in a lowercase n, that is what it's looking for. It takes my input value, forces it to lowercase, overwrites whatever was in again, and that is the condition that it's going to check. And this is what makes a while loop so valuable. For loops execute a specific number of times. I can mimic a for loop with a while loop to have it execute a specific number of times, but there are plenty of times when I don't know exactly how many times I want the loop to execute. And so a while loop, because I can actually change the condition inside of the loop itself, it allows me to change that condition in a variety of ways. Prompting the user for an input and using the value of that input as my sentinel value adds a tremendous amount of flexibility to the while loop.